This is the video for Unit 3, Lesson 2, End Behavior. So the goals for this section are going to be to identify the lowest degree of a polynomial and to recognize the relationship between the degree, end behavior, and also the leading coefficient. So we're really kind of starting to see what relationship do we have with the degree and the shape of the graph, and specifically end behavior. So what we're going to look at first are kind of some functions we already know. So linear, that's our y equals mx plus b. If I'm talking about the degree of this polynomial, this would be considered a degree 1. And obviously 1 is a odd number. So this is actually considered an odd degree function. The degree is odd. In this particular problem, you can see the leading coefficient is actually a 2, or it's positive. It's actually kind of what I'm also going to write here. And if we were to look at the end degree, the end behavior of this function that's linear, that's an odd degree, you can see that the end behavior is going in opposite directions, right? And when we read from left to right, we can see that this is an increasing function, which is typically what a function does unless it has a different leading coefficient. And as it goes to the left, and that's what this end behavior means, you can see this one's going down to negative infinity. As we go to the right tail is going to positive infinity, right? So this first one, nothing too different, but we can see the end behavior is going in different directions. Quadratics, we worked with quite a bit in Math 2, and the degree of a quadratic is a degree 2. 2 is an even number, so a quadratic is an even degree polynomial. And the leading coefficient for this example is a 1, but also I'm going to put that it's a positive, right? Because we're going to see when it's positive, it does something different than when it's negative. For this even degree, if I look at the left tail, you can see this one's going up. When I look at the right tail, it's also going up. So we're going to see that when we have even degrees, notice that they're going in the same direction. They're either both going up or they're both going down. Whereas if it's odd, they're going in different directions. And we're going to kind of see that with some of the other polynomials as well. The next one we did was a cubic, which we saw a lot in Unit 1. So for this example, it's a degree 3. That's what a cubic is. 3 is an odd degree, so I'm going to put that it's odd. On this example, it's a leading coefficient of 1, but I'm going to also write that it's positive because we're going to find again, what happens when it's positive. And we can see, so cubic is an odd degree. And if I look at the left tail, it goes down. The right tail goes up. And we can see, just like we saw with the linear that was a degree 1, this one also goes in different directions. So when we have an odd degree, the end behavior is going to go in different directions. And specifically, the left is going to go down, the right is going to go up. So when we go from left to right, it's going to be increasing. The fourth one we're going to see here is a quartic. Quartic is degree 4. Degree 4, that's going to be considered even. So when we look at even, same thing when my leading coefficient for this one's a positive 1. And when I look at my left tail, you can see it's going up. When I look at my right tail, you can see it's going up. And we're going to see when it's an even degree, it's going in the same direction. And that's the same that we saw with linear, right? So linear, or not linear, a quadratic. So with quadratic, it was a degree 2, same direction. Quartic, same direction. And you can see they're both going up. And specifically because our leading coefficient is positive for both of those, right? So one thing we're going to see is when we have an even degree, the end behavior is going to go in the same direction. And specifically, it's going to go up if the leading coefficient is positive, and it will go in a different, or it'll reflect our normal increasing way. And then if it's negative, it's going to look different. Odd degrees, our end behavior is going to go in different directions. And if we go from left to right, it's going to look like it's going to look like it's increasing. All the ones we saw, we had a positive leading coefficient. So let's see what happens when we have a negative leading coefficient. This one on the left is a cubic. And you can see, all right, so let's see what happens when we have a leading coefficient that's negative. So for this first one, we're going to see this is actually a cubic. And we've kind of seen a cubic already above where it looked like this, where you can see from when I go from left to right, the end behavior, it's similar to the end behavior for a linear when the coefficient or the leading coefficient is positive. When it's a negative, you can see it's going in a different direction, or it's reflected, right? It's starting high and ending low. So when this one, the degree is still 3, in this example, it's a -1 as our leading coefficient. And you'll see the negative leading coefficient changed our end behavior. So you can see when I look at the left tail, instead of going to negative infinity, it's going to positive infinity. It's going up. When I look at the right tail, it's going down. So you can see it flipped the end behavior from our original that we had. So instead of going low, starting low and going high, it's starting high and going low. So we're going to have you try the U-try problem. In the next example, we're going to be looking at double roots. So for the graph that we're looking at, we can see that this is going to be a cubic. It has a degree 3. So it should have 3 roots. But when we look at our graph, we only are seeing 2. We see one at -2, 0. We're seeing one at 1, 0. The one at 1, 0, you can see the graph actually touches the x-axis and then kind of bounces. It doesn't pass through. Whenever we have a root that's just on the x-axis and isn't passing through, we actually consider that to be a double root. So that's where we're getting that term double root. We're counting it twice. So if I was to look at it in factored form, you could see that factor actually appears twice in our polynomial. And so we're counting it twice, but we're only seeing 2 x-intercepts. So this is still a degree 3. Our leading coefficient's a 1. And so since it's an odd degree, it's going to end behaviors in opposite directions. And our end behavior is going to do what it normally does. So when it goes, the left tail is going down, the right tail is going up. And then our roots are simply just going to be -2 and 1, but 1 is a double root. So sometimes we indicate that with a dr. For the next example we're looking at, we can use our leading coefficient, our degree, to determine the end behavior. So our leading coefficient is a 7, and it's actually a positive. And our degree is a degree 4, which means that it's even. So what that means is our end behavior is going to go in the same direction, and if it's positive, they're both going to be going up. So if I want to determine my end behavior, that always starts the same way. What happens when it goes to the left? What happens when it goes to the right? And when it goes to the left, I can see it's going up to positive infinity. And when it goes to the right, I can see it's also going up to positive infinity. We're going to have you try the U-try. And as usual, if you have questions, feel free to ask during class, sign up for T-Bolt time, or go to the center.